The soft white loaf on the shelf is mostly air. Its whole body is a net of invisible threads, holding up thousands of tiny bubbles of trapped gas. Take the gas away, and the bread collapses to almost nothing. That is the hidden truth behind how bread is made in a factory, and it is one of the most interesting facts about the food we eat every day. So how does a pile of dry flour become a soft, sliced loaf in just a few hours? It starts as dust. Wheat grains are crushed and ground until they turn into fine, pale flour. Run it through your fingers, and it feels like powder. Nothing about it looks like bread. For the whitest loaves, the mills strip away the grain's outer bran and its tiny germ. What is left is the pale, starchy heart of the wheat, ground finer than face powder. Then water, yeast, and salt are added, and the mixing begins. But a factory does not knead gently by hand. Giant steel mixers slam the dough around with enormous force in a matter of minutes. And as they mix, something invisible is being built. A hidden structure comes alive inside the dough. Flour holds two special proteins. Add water and work them hard, and they link into long, stretchy strands. Those strands tangle into an elastic web. It is called gluten, and it is the secret skeleton of every loaf. This web can stretch and trap gas like a million tiny balloons. Without it, bread could never rise. It would bake into a flat, hard brick. Salt does quiet, heavy lifting in here too. It sharpens the flavor, tightens that gluten web, and stops the yeast from racing out of control. A loaf made with no salt tastes strangely flat and dull. Much of the world's factory bread is built on one clever trick. It was developed in a British town called Chorleywood. Instead of resting the dough for hours, the machines beat it with such intense energy that the gluten web forms almost at once. A process that once took most of a day is crushed into a fraction of the time. To pull that off, the dough gets a few quiet helpers, a little fat, a pinch of vitamin C, and tiny amounts of enzymes, all of them working to make the web stronger and keep the loaf soft for longer. It is why a factory can turn flour into finished loaves faster than a home baker can make a single batch. I find myself wondering where you are watching this from tonight. Bread is baked in almost every culture on earth, from a bakery in Egypt to a kitchen in Poland to a small town in Chile. So I am quietly curious which country you are in right now. Not the city, the country. Now, back to the dough. Inside that dough, an army of living creatures is waking up. Yeast is alive, millions of tiny single-celled organisms mixed right into the bread. They feed on the sugars in the flour, and as they eat, they breathe out gas, exactly like we breathe out our own. That gas is carbon dioxide. It fills the stretchy gluten web with countless tiny bubbles, and the dough slowly swells and puffs up from the inside. The yeast makes something else as it feeds. A small amount of alcohol, which later vanishes in the heat of the oven. So the fluffiness of your sandwich bread is really the breath of a living thing, caught in a net. Now the swelling dough meets the machines again. It is sliced into exact portions, each one weighed to be almost identical, then rolled, rounded, and dropped into tins, moving along the line without a single hand touching it. A single large plant can pour out thousands of loaves every hour. The line barely sleeps, grinding on deep into the night, one identical loaf after another after another. The tins roll into a warm, damp chamber to rise once more. The dough softens, relaxes, and climbs toward the top of the tin. Then the tins enter a tunnel of fire. The oven is not a box, but a long moving passage. The loaves ride slowly through it, going in pale and soft. In its first moments in that heat, the dough does something dramatic. It leaps upward in a final burst of rising as the trapped gas expands and pushes hard. So picture two loaves, one left pale and soft, one baked to a deep golden crust. Which would you reach for first, the pale one or the golden one? One word, pale or golden. Write it below. That golden crust is pure chemistry. The heat drives the sugars and proteins on the surface to react, turning brown and building deep, toasty flavor. Bakers have a name for that browning, the Maillard reaction. It is the very same chemistry that gilds a seared steak and a roasting coffee bean. Sugars and proteins collide in the heat and build hundreds of new flavors. No browning, no real bread taste. Deep inside, the loaf is changing forever. The soft dough sets into a light, springy crumb. The starch swells and locks into shape. And the yeast that did all that work now dies in the heat. It gives its life to make the loaf and never tastes the result. The bread comes out of the oven soft, hot, and impossible to slice. Cut it now, and the blade would drag and tear, smearing the loaf into a gummy mess. A hot loaf is not truly finished bread yet. So the loaves take a long, strange journey through the air. They ride slowly up towering spiral racks, cooling as they climb, sometimes for an hour or more. Picture a slow carousel of bread, winding higher and higher toward the ceiling. Thousands of loaves, drifting in the air at once, just waiting to lose their heat. Only when a loaf is cool does it face the blades. The whole loaf is pushed into a bank of thin blades at once. In a blink, the entire thing falls into perfect, even slices. That idea felt like magic when it first arrived. A man named Otto Rovetter spent years building the first machine to slice a whole loaf at once. It was such a sensation that we still call a great idea the best thing since sliced bread. And there is a stranger twist. During wartime, one country briefly banned sliced bread to save resources. People were so upset the ban did not last long. The slices are bagged in seconds and sealed with a small tag or clip. The bag is more than wrapping. Sealed fast, it locks the moisture in and keeps drying air out, buying the soft loaf a few more days before staleness or mold can win. In many places, those little tags carry a hidden code. Their color quietly marks the day the bread was baked, so staff can pull old loaves from the shelf at a glance. Now for the strangest fact of all, the one that hides in your own kitchen. Bread does not go stale simply by drying out. Something sneakier is happening. Inside the cooling loaf, the starch slowly rearranges itself, hardening and turning crumbly over the days. This creeping change is what makes old bread firm and dull. And here is the part almost nobody believes. This process runs faster in the cold. Bread left in the fridge goes stale quicker than bread on the counter. The chill you trust to keep it fresh is actually rushing it towards stale. The freezer is different because deep freezing stops the change in its tracks, but the fridge is a trap. So look at the whole impossible chain in one slice. Dust-fine flour, a web of invisible protein, the breath of a living organism, trapped and baked, a tower of cooling air, a wall of blades, all racing from grain to bag in a few short hours. And it hides a quiet paradox. We work so hard to fill the dough with gas, only to trap it. The holes are not a flaw in the bread. The holes are the whole point. Everything about a loaf exists to hold on to a little captured air. I still cannot get my head around one of these. That your fridge makes bread go stale faster, not slower. Which fact surprised you the most?